Hi everyone. So welcome to the first session of DeveLuP. So this session will be focusing mainly on LaTeX and how you can generate really good documents with it. So this is the overview of the session. We'll be taking a look at why you need to use LaTeX, what is LaTeX, what can it do best, and the last three parts will be just you creating a document on your own, and then we'll try to take a look at the document which created this presentation. We'll also try to understand. So typesetting is the way you present your content in a document. So LaTeX can do that very well. So let's start with why LaTeX. So LaTeX can generate a very high typographical quality of documents. It has a lot of inbuilt computations that it performs while generating a document to make sure it looks good. And another advantage with LaTeX is that it clearly separates the content from the formatting of a document. So when you're building your own document, you can just focus on the content while telling LaTeX that uh, separate sections of the content. Like you can say this part is a section and this part is a chapter, and LaTeX will take care of formatting based on that. And if you want even more final control and customization of the formatting of the document, you can do that too. So we'll be looking at that also in today's session. And as you can see, LaTeX is very stable. It's free and open source, so that's an advantage. One of the advantages when compared to other alternatives like Microsoft Word or OpenOffice. And it's portable and cross platform. So the output generated by LaTeX by default is in a DVA format, but today we have several other compilers which can generate in several other formats as well. So what is LaTeX? So LaTeX is essentially a markup language. You will type your documents as plain text, and the LaTeX compiler will make sure that it processes it and generate really good documents for it. And as you can see, it generates the source code. You use the source code to generate the documents. Initially, LaTeX was just aimed at writing scientific documents, reports, or articles, but now it has become very popular. And since it's open source, there are a lot of other type of documents and that can be generated with it. And one more advantage of LaTeX is that it's highly extensible. So users have been creating packages to go with LaTeX, and if you want, you can. There's one package called Perl Tech which can even generate dynamic documents by integrating LaTeX with Perl. So this is basically what LaTeX is. So and what can LaTeX do best? LaTeX it can mainly focus on. So the best thing LaTeX can do is creating is like typesetting math. So you can generate like beautiful equations as simple as these to something as complex as this one, which you can see here. And another thing which you can do is tables and figures. So as you can see here, you can generate a table like this, or you can add borders, and you can even do something like this. So one of the biggest advantage when compared to Microsoft Word or other Office tools are they have a GUI powered with them. Both LaTeX and Microsoft Word can do almost the same things, but the biggest advantage is that LaTeX does not have a GUI. It might feel as a disadvantage, but that's a very big advantage because when you're using a GUI tool, you can't have all the options that are available in front of you. So most of them will be hidden in menus and stuff like that. So so the tools like Microsoft Word and LibreOffice basically what you see is what you get, but that's not the case with LaTeX. When it comes to LaTeX, I like to call it what you ask is what you get. You just tell it what you want, and it will make sure it does that. And one common problem most of us would have faced with GUI-based tool is that, let's say you just completed creating a very beautiful document in Word or any other Office tools, and you notice that one of the paragraphs which you have, the content is not enough to describe what you want. So you end up adding one more line there. So now what this one line does is that it moves the image that's in the next paragraph down to the next page or something. So this effect just daisy chains down all the way to the document, and all the images and tables might get misaligned. So this does not happen with LaTeX. LaTeX makes sure that when you ask for something, uh, LaTeX makes sure when you ask for something, it just stays there no matter what. So we'll be taking a look at how we can do all of this in a while. So, and one more thing LaTeX can do best is add references. So like when you write important research documents or even any articles, it's important to have add references or bibliography for any of the content you have. So when you use word process like Microsoft Word or some other tool, you'll have to pay for another service which can generate like bibliography and tables based on your use case. So LaTeX can do that easily. You just need to add an entry in a file called bibtex, and we'll be looking at that too. So this is how it will look like. So this will be the citation which you do, and this will be the reference that's generated. So we'll try go ahead and create a first document, and once that is done, I'll start taking some questions over there. So in case like you don't have a local LaTeX installation, you can just go ahead and try out Overleaf. Once you sign up there, you can create LaTeX documents online. So so this will be the first document which you create. Every document has two parts. So with every document you have to, this should be always be the first line. So it just says document class, the default font size, and what type of document you're creating. So in this case, the document type I want is an article, and the base font size is 13 points. And then you start by creating the document. So begin document. So over here you have two sections for the LaTeX file. This part is your actual document. Anything that goes above that is called the preamble. So over here you can add a lot of stuff. So for example, the title first, and then you can also have the author, and over here you just need to add make title, and once you build that, you can see that it makes the title page automatically for you, and it'll already also include today's date, like the date of the build for the document. So if you don't want the date over there, you just need to add this date and leave it empty. So when you build it, you'll just ignore the date over there. So you can also add subtitles. Okay. So subtitles not supported by all the document types. So I believe only Beamer supports subtitles. So we'll also see what Beamer is in a while. So let's say I want the date, and now when you're making the content, there are several several content types you have in LaTeX. So the first one is called a section. So let's say first section. So over here I'm just going to import a new package called Lipsum. So you must have seen a lot of websites, they use something called the lorem ipsum text. So that's just a placeholder text, and LaTeX provides that as a package, so you can just use it directly. So as you can see here, you have your first section. So you can go as 3 levels deep over here, you can have subsection, which will be which will look like this, and you can also have a subsection. Which will look like this, and you can like repeat this as many times as you want. So when you create a lot of documents, something you'll need a lot is the table of contents. So LaTeX like takes care of that very easily. Over here, let me just add a new page and write table of contents, and then I add another new page over here. As you can see here, it created the title page. Just a sec. Yeah, it created the title page, and it created the contents field also. So there are some packages and commands which let you customize how this content page looks and stuff. So let me show you by changing the document type over here to report. You can see it changes a lot of things. It shows, it center aligns the content, it increases font size of the table of contents. So that's what, and you can also see that it changed the numbering style. So each document class has its own set of functionalities and formattings that are generally accepted. Sometimes the contents page might need two compilations to perfectly render. So this, yeah. So on other types of sections, you can have this chapter. So this is just a first chapter, let's say. Yeah, so it has the first chapter, and you also get an entry for that in the table of contents. As you can see, in this case, the depth level of table of contents is 2. So you'll have 2 level of depth inside each entry. So you can see the first section here, the first subsection, but you can't see the first subsection. And similarly, you can have paragraphs. So paragraph basically adds an indentation over here, but it does not make any entry in the table of contents. But if you can change, like if you change the depth level of the table of contents, it will make sure that it adds that also depending on your depth level. So the next thing you can add are images and tables. Let's start with table. Let me add it over here. Yeah. I'm adding a table. So the table creates a table environment. So anything related to the table you can add over here. For example, you can add a caption over here in my first table, and you can add a label too, which for this table called my table 1. So the caption just adds a caption to the table. This label has another use, which I'll come to next. So while creating a table, to define the number of columns you have, just use the same number of characters over here. Let's say you want 3 columns, and all those 3 columns have to be center aligned. So just go C, C, and C. This means you need 3 columns, and all 3 columns are to be center aligned. And let me add some content here. and backslash in any place means a new line, and inside a table it means a new row. So let me build this. As you can see, the table is created here. Let me center. So this center environment makes sure that everything inside that is horizontally centered. Yeah, so let me just, okay. So as you can see here, you have one row. I'll add another row. Yeah. So as you can see here, depending on the content that's present in the column, the width of the table automatically adjusts. So let's say you want like vertical lines between the columns. So let's say I want the vertical lines to be between the first and second and third. In that case, I just add a pipe symbol, pipeline symbol. That's not null, that's a pipe symbol, and then I just build it again. And as you can see, it has added the two lines over here. Let me just, yeah. So as you can see, it has added the two lines. And if you want it outside the table too, just needs adding the lines. As you can see here, the lines have been vertical lines have been added. Now let's say I want a horizontal line between each row. So at the end of each row, I just need to add H line. So that just adds a horizontal line in between. So LaTeX is pretty intuitive. So if you need something, most probably what you need is the command for it. And so over here, if I change this C to an L, L meaning left aligned, you can see the content gets left aligned over here automatically. And one more thing you might notice over here is that, let's say I add some more content over here. No matter how much content I add, the table always stays at the top. So this is one of the advantage of LaTeX, is that it will stay where you want it to stay. So by default, table always stays at the top of the page. So now if I want it at the bottom of the page, I just add a B over here. Anything inside the curly braces are called arguments, and everything inside the square brackets are called options. So that's the general terminology. Now if I build it, you can see the table has moved to the bottom of the page, and it will always stay there no matter what content I add and where. And so what if you want this table to stay with the flow of the content? So let me just make this a file here. No. And I add this over here. So let's say I always want the table to stay in the same place related to these two lines. So I just change this B to a H. So H basically means here, as in like stay here. So when I build this, it will stay in the right place. As you can see the line. Hi, there is some content. Hi, there is some content. So it will make sure your content stays after this section always. So we've seen this label part, right? So one use of this, if you want to, is when you want to refer this table somewhere. So let's say I want to refer this table over here. Let me remove this line. Look at table over here. I add ref, and the name, the label we use for the table. So this and this, if they are the same, it will be referred automatically. As you can see here, it's like look at table 1.1. So the table numbering is basically the section which is in dot the table number. So over here you'll automatically get look at the table 1.1. So next, to add an image, you also have an environment called image, or you can just directly add it as include graphics. So I already have an image in my present working directory. So I'm just going to add a dsc.png, and when I build it, okay. So images need another package called GraphicX. So okay, so the image is probably too big. So I can adjust the width over here as, let's say, 1 centimeter. The image is over here right now. We'll just raise it a bit. Yeah. So this is one way to adjust the size of the image. You can add a width, or you can even add a height. So the height will make sure the height of the image is always 5 centimeters, or you can just scale the image. So scale it as 0.1. And this is the size of the scaled image. Now let's say you want the image to be like 1/4 of this width, like 1/4 of the total width of the document. So you can just go width equals 0.25. So here you can use some inbuilt commands. Just add text width. So 0.25 corresponds to 1/4, and you can see here that the document, the size of the image is the same as 1/4 of the size of the text. So this is how you can include images over here. And yeah, and when it comes to formatting a document, let's say you want to make a text boldface or italics, or you need to add emphasis to your text. So you can do that by using, let me go, okay, I'm adding a new section called formatting. So here I have some text that needs formatting. So let's say I want some text to be bold. I just do text BF. So BF stands for boldface. Similarly for italics, it's text IF, so text IT, and if you want emphasis, EMPH. So this is text bold, and text IT would be italics, and let's say need formatting to be emphasized. You can so you can see here the text is bold and the formatting is emphasized, and needs is in italics. So the emphasis changes based on how your text is currently formatted. So let's say the entire thing is in bold. Yeah. So let's say your entire text is bold, and in that case the emphasized text will be in bold italics. So in case your entire text in italics, your emphasized text will be in normal font. So that's how the emphasis works. And when it comes to math, so let's say I want to add some equations or stuff. Math. So here I have a few, let's say I'm adding a few equations that go x plus y equals 10. Yeah. So as you can see here, if you move this to the bottom, so no matter how much space you add in your document, it will all be reduced just one one block of white space. If you want to force a space somewhere, you just use space command, or new page if you want a new page, or backslash for an empty line. So I'm just going to add a new page over here. As you can see here, you have everything after this new page, the new page. So this is one. So this is some basic math. Let's say you want to add some complex math with some Greek variables and stuff. So all the Greek variables are inbuilt as commands. So let's say I want a sigma, and oops, yeah, and I get a sigma over here. So let's say I want the capital version of sigma. I just make the first letter caps and I get the other sigma. Now let's say I want to use it as a summation. So I just go sum n equals 3 to 10 and x. So in LaTeX, anything followed by the underscore in LaTeX is used for subscript, and the like arrow symbol is used for the superscript. So as you can see here, n equals 3 is added below the summation symbol, and the 10 is added above. So there's another environment called equation, like the table environment which you saw here, and there's an image environment, and there's another environment for math called equation. So now, so when you're using equation, you don't need the dollar symbols. You can just use it as is. Now if I build it, you can see the equation gets centered. It's and the formatting changes, and you also get an equation number. But if you don't need the equation number, you just add a star over here. Okay. Okay, so that probably needs another package for math. So this is how the equations work over here. So this is some basic LaTeX. As you can see here, all the sections are being added, all the chapters are being taken into account. So I'll pause over here, and if you have any doubts so far, just add it in the comments or in the live chat. Okay, so one question I see is, can you give image size and pixels? So there are different different metrics for the image size or any length you can use. So one of it is centimeters, and one of it is relative size called EM. It's used a lot in web development based on what I've seen, and you can also use the PT formats which are used here. So PT is basically the same that's used in Word, I believe. And yeah, so any questions right now? Okay, so another question, that package is stored in which directory? So most of the LaTeX installation by default comes with a ton of package, and if you want to manually add a package, you just go to ctan. So let me just show you ctan. So the comprehensive text archive network, you can look at all the packages that are available here. So graphic X which are used here, it's available here. You can see the documentation if you want, the readme, the guide, so everything will be present here. So yeah, how to specify the page number? Okay, so to keep track of the chapter number and the section number and the page numbers, LaTeX uses something called counters. So you have a specific counter for the chapters and specific counter for a section, specific counter for the page numbers. So you can control that using that specific by setting the value of that counter. So I'll come to that in the last part where we take a look at a different template. So that includes all that. And one more thing, you can also change the paging, like the numbering style also. So page numbering, let me say Roman, and you will see all the page numbers are changed to Roman numerals. So I see another question by Akhil that says, okay, that was deleted. So is this a Google product? No, it's an open source tool. So I believe it's been in existence for a long time actually. I'm not sure about the year, but initially it was created for scientific documents. It is open source and it was open source, and it's not a Google product. So there's a question by Akhil called table BW2 para. I don't understand that. So can you just format it properly? Yeah. So table between two paragraphs. Yeah. So as you can see here, this table I've added a H option, which is here, and it's between two sections. I can just move it to any place I want as long as the here option is enabled. So if I move it here, it'll just go there. Any keyword for printing result. So by default you can configure this one to build in any way you want. So the current compiler I'm using is called XC LaTeX. So I use it for most of my purposes because in some kind of documents it generates slightly better results. And so I've set this up to build it using XC LaTeX and then display the PDF over here. So when you use editors like this, you can configure all that. Okay. So any other questions? Okay, so there's one question. Hey, there was no sigma used in equation code. Was it automatically added? No, like over here you can see the command called sum, right? So in math, summation is basically it's just the sigma symbol. So if I just change that to prod, I get the mathematical product symbol, the pi. So there's another question, what is meant by undefined control sequence? That means the command which I've used is wrong. So maybe you have a typo or the command doesn't exist, or you may not have included the package. Where will we get all the commands to be used to make a basic document? So Overleaf has a very good tutorial section to get started with LaTeX. Let me just show you. So to get started with LaTeX, this will be very good. It will show everything you need. Yeah. So this will also cover everything I've spoken so far. Okay, now let's move on to looking. So in the starting, I showed this presentation, right? PPT. So now let's take a look at the tech document that created this presentation. Okay, so this was the document that created the presentation. So when you create presentations, the document class in LaTeX is called a beamer, and there are several themes that you can use. So I've used something called Madrid. Let me just show you all the other themes that are available. Yeah. So, like these are the list of themes that you can use. Berkeley, Begin. So you have a huge bunch of themes, and you also have specific styles for each of those themes, which adjust the color palette used and the structure of the presentation. So these are all the possible combinations you can make. So all these links I'll share it as a mail once the session is done, so you can explore it when you need it. So going back to this, so and so this is basically an input encoding package for UTF-8, and AMS Math is used to handle math at a bit more advanced level. And so this is to adjust fonts, symbols, graphics, and to handle URLs. So if you want like your clickable links inside your PDF, so you just need to use this URL package. So one more thing that comes with uh, the Beamer template is a command called logo. So all it does is, once you pass an image and with the proper scaling, it adds that image to the right place in all your slides. So for this specific theme, it feels as the right place is over here. So so if I change to something else, like let's say Berkeley. Okay. Second. So when I change the theme, it will automatically adjust that to fit the right location. So in this PPT, as you can see, now the logo has been moved to the top left because LaTeX feels that will be the right place to put it. So a lot of computation goes inside LaTeX to find out what's the best way to to create your own document to make sure it looks good. And you can also add your institution details if you want, the date, and the subject and stuff. So when you handle Beamer documents, each slide is called a frame. So the first frame, it just contains the title page, which Beamer created by itself. I mean LaTeX created by itself, and in the next frame I have the table of contents, which was also done by LaTeX. And next you have this. So this command, like LaTeX written in this format, basically shows the LaTeX logo, the actual logo. So you can use that in the documents if necessary. So, and this environment called itemize is used to create unnumbered lists. So if you want bullet points, you can use this one. So if I change this to enumerate, so here I change it to enumerate and I get a numbered list, as you can see. So this is how lists work in LaTeX. And yeah, so you can also nest lists inside uh, an item in a list. So over here I'm just adding another list inside an item. So let me just format that. And as you can see, I have list inside a list. So you can do even that with this itemized environment. and each item in the list is preceded by an item command. And this item command can basically hold anything. You can hold a paragraph, anything you want. So, and again, so the equation which you saw here, the weirdly complex one, so it was generated by this one. And so over here it doesn't look that good because the pi, uh, the limits of the pi is not proper over here. So I just use the equation environment in this case. So a lot of the programming languages have comments, right? So in LaTeX, if you need a comment, you just add the modulo symbol. So the modulo stands for a comment. You build that, and you get a much more cleaner version of the equation when you use the equation environment. Okay, so and one more thing in LaTeX is the pause command. So I haven't used it here. Yeah, I have used it here. So uh, when you use pause, what happens is it adds that particular line, as you can see here, in a separate slide. So when you're presenting it, it gives you the illusion that each one is like it's like an animation. So with each moving slide, a new line will be added when you use a pause command. So that's about the document that created this. So if you have any doubts, please let me know. How to get a pic. So just make sure the picture you're using is in the same directory as the text file. If it's not the same directory, so you can add the complete path over here. So in this case, I will just use dsc.png. So instead of that, I can just add the entire path like home slash something or images slash something. So as long as the image is in the correct directory and you point it correctly over here, it will work fine. So does underscore an equation or math meet part in text? Yes, underscore means subscript, and it will work only if you are inside a mathematical environment. So you should either be inside the $2 symbols or inside the equation environment. And can we change the default font style of report, or is it fixed? So everything in LaTeX is customizable. You can even change the font style. So you make it use system fonts if you want, and you can also make it use some other external fonts as long as you provide the necessary files for it to build the font. Yeah, so in this case, you can see that you can like change the command of family default to some other default font. I'll just show you what these individual command means in the next section. So any doubts? Okay, so yeah, uh, I see Gandha Deva asking a question like you're having some problem with the width of the graphic. So you must mention the dimensions as in width is equal to 0.25 centimeters or 0.25 of the text width. So in this case, I've made it 1 centimeter. So I can change it to like 0.5 of the text width, and it will change it accordingly. So it became this big because the text width is that big, and just became half of that. Okay, so let me move on to the next section then. So we'll be looking at a bit more complex document. So this document, like if you're in SASTRA, you might end up using this document also. So in your final year report, you'll have a separate format that you need to follow. So this document, make sure you follow that. So I call it the project template. I'll share the link in the chat right now. Yeah. So this is a template that I created, and it looks something like this. You have all this. So this bona fide page, the title page, and the declaration page, everything gets automatically generated as long as you give the necessary information. So you can see here that the document class is something called project report. So that is a class I created for this document, and there's a new package called project report commands. So these two are the packages and document class that I created to make building this document a bit more easy. So here you'll find a lot of new commands commands that possibly can't be in the uh, inbuilt LaTeX. So it's called define student name 1, define student register number 1, define student title 1, define the program, define the guide, define designation, and all that stuff. So all this was created by me, and I'll show you how. So the first thing we'll look at is the document class. So you need to create a new file called the project report called .cls. So CLS standing for class, and you must make sure the first line says it provides the class project report, and you can add some other options if you need it. And you can load a default class it uses. So in this case, I've made sure that it uses the default class of report, and it uses a lot of packages for different things, and it's one is for color and one is to adjust table of contents and stuff. And over here I define a few colors. So I say the dark green one must have a red, green, and blue value of these, and the gray one should have a green, blue value of this, and so on. And this basically LST set lets me create a listing for something for for specific purposes. So in this case, I'm using it to add a code. So to add this source code and do automatic syntax coloring, I'm using this particular environment. So, and I'm creating a new environment called hyphenated code, which will make sure this all syntax coloring is automatically done. And I'm also setting the geometry, which tells what's the page size, what are the margin dimensions and stuff. And I'm also adjusting how the table of contents must look like. So there's a package called TOC loft, so which lets TOC loft title TOC and title sec. So all these lets you adjust different parts of the document, like the title of the section, title of the chapter, the title of table of contents, and all that. So right now I'm adjusting the title of table of contents, as in the title of the chapter that's shown in the table of contents. So I'm just saying in the left I need no space, and before that I need nothing. And so in the entry I need the contents label of that chapter and some space. And following that I need an empty space followed by the page number that's given by the contents page command. So someone's asking what link is that which I shared. So that's the link of the document which I'm going through right now. You can use it later for understanding how different commands can be created also. So like that I'm adjusting different. So like I adjusted the chapter, I'm adjusting different parts of the document, like this title of the section, table of contents, the title of figures, and stuff like that. So this basically the class file basically defines how your document must look like. So you must have noticed that yeah, so the table of contents looks a bit different. This is not the traditional table of contents which you get. Sorry. So in general you don't have this title field, the page number, and by default it doesn't change the numbering in between. So all this you can do by adjusting that. And for someone who asks how the numbering is changed, so here you can see the page numbering is initially set to Roman, and in the middle I change it to Arabic. So Roman is the Roman numerals, Arabic is the normal numbers which we use. And to change the page number, I use this command called set counter. So I need to change the page counter. So I just say set counter of page, and the second argument is what value I need to hold. So similarly, I use a set counter for the chapter number and stuff. Okay. So yeah. So when it comes to creating a new command, there are two arguments which the new command takes. So let's take a look at this line. So a new command has two arguments. The first one is the name of the new command. Let me just call it some new command. And the second argument basically says what that command does. Let's say it just returns hello, my name is Vishal. So what happens now is when I call this some new command, it will automatically like return hello, my name is Vishal. Now let's say you want the user to be able to set the name that's printed over here. So for that, all you have to do is add an option over here which says the number of arguments that command can take. So in this case, I just need one argument. So I'm just saying 1, and then over here I just say #1, which says hello, my name is, followed by the first argument that's passed. And in LaTeX, the indexing of arguments starts with 1. So just make sure you remember that. Okay, so in this, let's say I need two values for the first name and the last name. So I just add number 1 and number 2. I go to text. Let me just add it over here. New command followed by Vishal followed by R. So now when I build it, yeah, you can see my name is Vishal R. If I change it to, let's say, John Doe, you can see that it changes over here also. So this is how you create new commands to do what you want. So a command can do like anything you want. It can be as simple as this over here, which I created, and a command can itself create a new command. So let's say you need some new variables which you are going to use in a different command. So to define that, you just have a new command. In this case, it's called define student register number 1. It takes one argument, and what it does is it creates another new command called student register number, which uses the argument which was passed during the first command call, which is define student register number. Once you look at it, you'll understand that it's a bit intuitive on how to use it. And your new commands can be anything as simple as these one-liners you see here to something as big as this. So in this case, I'm just creating the first page by myself. So I'm doing the centering I want, adding the content, adding the formatting, adding the spaces I need. So all this I'm creating new command for that, so I can call it wherever I need. So this is how a LaTeX works, and so this command is a bit interesting. Let's say you have sections and you don't want it to not just sections, you just need to add a new entry into your table of contents without adding a new section or anything. So this command basically does that. Add contents line DOC chapter 1. So instead of repeating this again and again, you can just use create a new command to do that, and let it use it wherever you want. So since I've done all this, you can see the creating of the document is just pretty simple. You just need to pass the data, that's student names and stuff, and the guide names, programs, just the things that will be needed in creating the content. And then you just say, like, make the first page report, make the first page, create the bona fide, create the declaration, create the acknowledgement, and then create the table of contents and create the list of figures. So list of figures and list of tables are inbuilt in LaTeX. So it will automatically add a list of all the figures that are present with the page number, and the same will happen for tables also. So as an end user, like if you're going to use my template, this is all you'll have to do. Just set the data and use the right commands to do what you want. And so I didn't speak up to one thing yet, the bibliographic part. So when you're adding references, I said that if you're using tools like Word, you'll have to type it in the format that a particular journal accepts, or stuff like that. So what you can do over here is, let's say, yeah. So in this case, you can see that I'm citing a document over here. Or let's even go back to the presentation I used. So over here, you could see that I was citing a document in the bibliography page. So cite space doc. This is the label of the article. So what it does is, you'll need to create another file with the same name, but the extension will be .bib. So standing for bibliography or bibtex. Bibtex is another tool which helps LaTeX handle the bibliography parts. So over here you can see all this information about the document is present. So you might feel that like creating all this information is tough. So one way to do this is, like, you can type it on your own, or most of the like journal pages or most of the publishers provide it by themselves. So in this case, I'm just going to Science Direct, which is a popular site. I'm just picking some article at random. Now let's say I want to add a reference for this particular article. In that case, I just go to export citation to bibtex. So it will download a bib file for me, which when I open will look like this. So it will have all the information needed. So you can just copy this and paste it into your own bib file and use it as you need it. So this is how LaTeX makes bibliography easy. So far this is the end of this session, I believe. If you have any doubts, you can mail the DSC SASTRA's email, so which is I've added the email of DSC SASTRA over there. So you can find the chat, the email ID. So just make sure you add and the name of the session in the starting of the subject of the email, so we'll know what you're asking with regard to. And thank you for attending the session. Bye bye. And for the SASTRA students, you can ask your questions in Slack. So I'll be active there for an hour or so. And that's it.